Okay, use the shell method to get the volume, just like the prior problem. They got a region, and we're going to do about the y-axis. So what I want to do is go to the whiteboard again. I need a little space to do this. And we're doing problem number 2 now. And let's just make sure we know what number 2 looks like. I have y equals x squared, relatively simple. I have y equals the root of x. And I'm going to draw a picture of that, what it looks like to me. This looks like y equals x squared, and y equals root x looks like this over here. Points of intersection, relatively simple. That's going to be what? 1, 1. And this point over here is 0, 0. What's the region? That's the region. What are we going to do now? I'm going to do the rectangle again, and this is the rectangle right over there. So let me draw that down for you. It looks like this over here. Whoops, sorry about that. All right, what am I going to do? It actually, when you rotate around, it looks like a cylinder with a hole cut in, like a can or a shell. And we're going to just cut it open, and it's going to look like this over here. All right, what's the differential? dx. What's this thing over here? Let's see, 2 pi. Well, just like the last problem, the radius is going to be x. What's the height of it? Well, let's look at that. It's going to be upper minus lower. The upper curve is actually root x. The lower curve is actually x squared. I am now ready to write down the volume of that box. What's the volume of the box? 2 pi x times root x minus x squared times dx. What are the x's going between? 0 and 1. Hard to miss that. Again, what's my encouragement to you? Probably looking at the answer key to make sure that that's what you're staring at. Not a memorization skill, but a reading skill and an understanding what you've read. If you can translate it into an integration problem, that's great. Let's go for the simplification. So I'm going to pull out a 2 pi. I'm going to simplify the integrand by expanding it. So x times the first term. Well, that's going to be x. It'll be 1 and a half, which is 3 halves, minus x cubed dx. I'm going to integrate now, 2 pi. The limits look nice, by the way, 0 and 1, very simple to deal with. So what do you do? Increase the exponent by 1. That's going to be 5 halves. You're going to divide by 5 halves or multiply by its reciprocal, which is 2/5, minus x, increase the exponent by 1, divide by the new exponent, which is 4. Limits of integration, 0 to 1. Got to pop it in now, 2 pi. That's going to be 2/5 minus 1/4. Boy, that was simple. 2 pi. And if you evaluate the lower limit, both of those terms are 0. So what do you get over here? 2 pi. Between 5 and 4, the common denominator is actually 20. What do you get there? 8 minus 5. So what do you get? 2 pi times 3 over 20. I need to reduce that. That's going to be 3 pi. 2 goes into 20 10 times. Again, look at the key. Make sure you're looking at this answer over here. And if you're not, there's something wrong, all right? Mistakes happen. I think in a prior problem, you remember I made a mistake in the subtraction department. I look back over my work and maybe I made a mistake more than once, but the bottom line is I try to resolve those issues, all right? I really do. I don't say, oh, it doesn't matter. It does matter. Thank you.